Good morning and welcome. I appreciate you taking time out of your schedules at PAC Expo to attend this session. I hope you'll leave this session with a couple of good ideas and some useful information and some insight. I'm Brian Yurkiw. I'm Vice President of Business Development at ARBOR Solution. ARBOR Solution and ARBOR Technology is a 20-year-old company, and we have been doing a broad portfolio of industrial PCs for about 20 years. We manufacture tablets which fit this particular area, the rugged tablets, and they're sold into transportation, logistics, warehousing and distribution, field service, industrial automation, and healthcare applications. This particular talk, I'm going to discuss innovations recently in mobile computing and how these weave into M2M, which is machine to machine, and also into IoT, which is Internet of Things, and the developments that have fielded in that area lately. My hope is that you'll leave this session with a couple of ideas that you can take and leverage in your work lives. I want to start this talk right now with what is emerging right now, because there is a fundamental trend that is happening, and it is very mature, and that smartphones are permeating the mobile computing market. It may seem like a statement obvious, but what we get to is the technology in the smartphones is an incredible integration of a huge number of sensors. That integration includes things like communications, GPS, digital compass, accelerometers, gyroscopes, barometers, a whole bunch of things that only your kids would understand what they're there for. The net result out of this is the success of the smartphone in the market is they've delivered huge volumes to manufacturers that industrial manufacturers of PCs can now leverage. The implication of that is business devices will continue to need special features and functions that are applicable to the application and the market they're in, but they have the benefit of those volumes and the cost reductions that come from those volumes. The business systems deliver 4 or 5 or 6, depending on how you want to call them, features that an industrial PC would require. It's things like drop and shock protection, sealing to various levels, temperature tolerance. In a functional basis, it's barcode reading, near-field communications, RFID, docking, hot swap batteries. Those are things an industrial PC would require in a mobile environment. What has happened as a result of smartphones is the fundamental technology costs have dropped. So what used to cost substantially more is now substantially less, and as a result, mobile computing is going further and further into the environment, the industrial environment. It's permeating everywhere. Lastly, because it's tied to M2M and IoT, the recent developments in machine-to-machine communications and Internet of Things is introducing new underlying advantages and opportunities for mobile computing and the applications that they're supporting. So this is the environment that we're actually speaking to right now. This talk is going to go through fundamentally about 5 sections. I'm going to discuss mobile computing in a historical perspective because it is fairly new to the packaging industry. I'll go through past and now. I'll discuss machine-to-machine and Internet of Things very quickly. Then I'm going to discuss business opportunities that this technology presents, and I'll go through a couple of concrete examples. Particularly, I'm going to do 3 of them in terms of where we can actually get the opportunities, and then we're going to go with conclusions. Let's start where mobile computing began. Mobile computing in an industrial setting is actually fairly mature. It was first deployed in the 70s for essential business practice where people needed a computer at the point of deployment. They started as handhelds, they went to notebooks, they went to personal computers, and if the device was highly mobile, they migrated across that into tablets, which is what's happening today. Highly portable applications need tablets. While all of this was going on, and I put it in the bottom left-hand corner here, a social phenomena emerged. I don't like to call Apple a social phenomena, but we're going to call them a social phenomena. They started with an iPod, then they did an iPod Touch, then they did an iPhone, then they did an iPad, and what does it really mean? Tablets have been around for a long time. They used to be called pen computers about a decade ago. But what's happened as a result of Apple is Apple's taught the masses how to touch. We all know how to swipe, we all know how to pinch, we all know how to zoom, and the result of that is the workers in the industrial complex now want that as their user interface. So Apple's gone and taught everybody how to touch, and the people who are doing it at home are bringing it to the workplace, and I'm saying, I want that now. And industrial PC vendors are responding to that with products and services that can mimic that user experience. It does migrate to the industrial complex. The roots of mobile computing, and this is still what I'm talking about, come from the first applications that deployed, and they were fundamentally field service, mobile dispatch. The field service sector is about 40% of the mobile computing market in an industrial application right now in the rugged area. And I like to summarize what it is to give people a simple concept of what is mobile computing in that complex. I call it the 4 rights. It's a very simple concept. You've got to get the right person to the right place at the right time with the right information and tools. That's what started in the 70s. That was what was driving the organizations. It could have been a utility repair person. It could have been a field service technician doing residential repair. It could have been a police officer responding to a disturbance. That was all dispatch. The mobile computer was required in that application to respond or to take the electronic data from the system that was supporting the dispatch. The systems started just with computer-aided dispatch. There was a convergence in the market after that began deployment, and that convergence was GPS because it was very valuable to have location data on where the person being dispatched was and where they needed to go. The next convergence, which is happening right now, is telematics. It's a fact. A mobile worker who is dispatched large distances is driving a vehicle, and the telematics of the vehicle can add to the opportunity. And then lastly on this, M2M and IoT are suggesting or presenting opportunities now as they communicate to the systems that are reporting these mobile workers or supporting these mobile workers. So IoT and MOT have capabilities, the system supporting the working in an industrial complex. What is M2M and IoT? These are definitions from Wikipedia. I'm not going to read them, but fundamentally, M2M has been with us for a while. It is fundamentally devices that are reporting their status, and they're reporting them with simple information that is fielded, and they're reporting them through. A couple of examples that are fairly mature. A copier, as an example, reports usage remotely and will run internal diagnostics and report the results of those diagnostics. In IoT, which is newer, it's business assets that report periodically what their status is. In a couple of scenarios, very simple ones, they could be reporting status messages and the system is actually waiting for a message to be missed to realize that something has happened. Or it could be they're reporting their status as an exception, and then that exception is generating an action item to do some type of action to respond to the exception. What was driving this as it came along is fundamentally that systems that support those data collections are now sophisticated enough to take the millions of data points, take them into a system, massage them, and turn them into information, not just data. And that data or that information with M2M and IoT has the capabilities of being able to assist the mobile worker and make the enterprise more competitive. This activity was supported by what I call 4 technology enablers, and I'm going to summarize them before I get to the examples. The first one is computing. Cost-effective computing solutions in a huge variety of form factors are available today, and that computing power can be brought to the point of need, whether it's in front of a machine, in front of a patient, or in front of a criminal by a police officer. Communications. Wired or wireless communications is now available virtually everywhere. We talk on the wireless side about Wi-Fi, WAN, satellite, data communications. They're all there. We're in a connected world today. We all have our cell phones. We're using them right now. Carrying that along, the previous separations between voice and data are getting more and more blurred. There are opportunities with voice as well as with data, and when you put them in the same device, a voice device that is bidirectional, that can talk in either direction or be called, it is full duplex, supports opportunities in a mobile environment that previously were very difficult to do with just a computer. And lastly, location-based data. GPS is virtually everywhere now. In industrial applications, it used to be a huge premium. That premium is not there now. Everybody wants GPS information, and you want to know not only where is the device, but where does the person holding the device need to go. That's one of the enablers as well. And lastly, and this is IoT and M2M, the business systems required to support those data streams are now sophisticated enough to be able to take that information and to meld it together so it can be used for practical purposes. Those are the technology enablers that are present today that are presenting enterprises opportunities. I'm going to go through 3 concrete examples of how this can be used in various areas. I'm going to talk about a processing or packaging plant. I'm going to talk about a hospital facility or a healthcare facility. I'm going to talk about a field service, electronic field service repair service, and what IoT means to that and advanced communication. Let's talk about the example on the processing packaging plant. What happens with its new technologies allow the assets delivering the product, leaving the facility, to report the business systems that are driving the plant. It obviously could be performance. Did the machine break? Is there a problem with it? Is there an interruption of service? But it could also be material handling. Those are there right now. Where do these opportunities get to concrete examples? Let's try a few of these. Maintenance in an industrial complex can move from preventative to predictive. If the machine can tell you when it's broke, there's no reason to do a preventative maintenance routine until there's a reason for doing it. And why do you do that? Because the people who design the machines typically set the preventative maintenance schedule for the worst case scenario, not the average. So there's an opportunity there. You only work on a product, you only work on a machine when there's something to do. The communications infrastructure and the systems receiving the data are now sophisticated and consolidating data sufficiently that a worker who's dispatched to the machine can get substantially more information with the dispatch than they previously did. I'll talk about this earlier, but fundamentally the technician that's going to the machine has already got the report from the machine about what is wrong. The net result there is he or she knows what to repair and what to do, and on a more candid comment, and they know not to touch anything else because they may cause problems instead of helping. And lastly, since this is a facility producing something, the opportunity with IoT and M2M suggests this, that you can do seamless optimization all the way from the raw materials entering the plant to the finished product leaving. And if this was food, it's probably going to the point of consumption as well. So the opportunities in a processing packaging plant go from source all the way to the consumer at the end. Let's take my next example. This is a hospital, a little bit more distant from a PAC Expo, but let's talk about it because they're parallels. The productivity opportunities in a healthcare facility, in a hospital with remote monitoring are interesting. Normally you would think of a nurse doing rounds to check on patients. Think instead of a healthcare professional in front of a large screen TV watching multiple patients who are instrumented simultaneously, and they only go at the time when the patient needs help. It's kind of like the machine we just spoke about in the other plant. In this case, it's not a machine, it's a human being. I appreciate that, but it is the same scenario. Storage technologies are also available in that scenario right now to store key medical metrics that are being delivered, and the systems can automatically report transitions, they can report alarms, they can report thresholds, so people are acting on information delivered to them rather than periodically checking if the patient is still okay. And lastly, this introduces something very interesting in a high-cost healthcare environment. You could, in this environment, dispatch a patient who is less at risk so they can recover at home and monitor them remotely and only dispatch when there is a critical situation developing or a situation developing where there is a requirement for a professional healthcare person to be there to help. So that's interesting. Now the next one comes, and this is more normal for mobile computing. We have the capability with mobile computing to automate some of the healthcare processes, and I think of checklists. We use checklists in a lot of areas. You can use it in healthcare. The benefit of a checklist on a mobile computer is nothing is ever forgotten, provided the checklist is correct. The next one on this one here is an obvious one. One of the risks in a medical environment is, am I giving care to the correct patient? That may seem pretty trivial, but if you've got RFID and you've got barcode reading, that should never even be a conversation point. And then the last one on this one here, which is what about patient care? I can do delivery of medications on time at the right frequency, and I can monitor it and track it. I can do therapy at the right frequency in the right point of care, and then I can link those very closely to billing, to inventory control, and all of the things that are required in a healthcare facility to make sure that I am getting timely and accurately and auditable billing. That's the opportunity in that type of facility with M2M and IoT. I started the discussion here with a background in field service. I'm going to use M2M and IoT in this environment as well. Remember, I started this one saying field service is a very simple concept. You've got to get the right person to the right location at the right time with the right tools and information, and that still is there. The scenario does parallel to the one in the hospital and the one in the industrial complex. Operation efficiencies for mobile computing is broken down by the little graph in the bottom, and I like to think about it in just two areas. A job has administration parts to it, and then it has the work. The CAD scenario I told you about earlier, and the GPS, and the mobile device, fundamentally at that point in time attack the administration portion of a job, getting the right person to the right place at the right time, and then to collect information to close it off for billing. That's the administration portion of the job. M2M and IoT presents an opportunity finally for a service company to attack the work itself. When in 10 years ago, when people spoke about a job, the job was fixed at an hour and a half, 2 hours, whatever it was, the job was the job. When you broke the job down, there was a diagnostic portion, and then there was the actual work. If you think about M2M and you think about IoT, we have the capabilities of sending a technician to a point of work with the information already required about what he or she has to work on, and the diagnostic portion at the very least is reduced, at the very most is eliminated. So we have an opportunity in a field service area for being able to assist greatly on a part of the job. In this scenario, it is usually 2/3 of the work. Lastly on this, what about voice? There's a very superficial benefit from a voice-enabled device that we ought to always keep in mind. Most enterprises, for safety and for efficiency, are giving their field workers two devices. They're giving them a cell phone and they're giving them a computing device. If you put the two of them together, a smartphone, at that point in time, you will eliminate somewhere between $30 and $70 per user per month in communications billings. And that's not trivial. It gets to a point with a device that's cost effective that you could probably get your money back for that investment in the first year just in communications costs. So that is absolutely imperative. But I also want to add on this, using field services as an example, voice is there to support a mobile worker away from a point of origin for safety, for collaboration, and things like that, but it's also there for camaraderie. So if their business tool is also their communication tool, they're more likely to use it all the time, and they're more likely to use it properly and effectively. That's the benefit of that convergence between voice and data in a field service environment. So I want to reiterate this just once more, but from a technology pointer. The CAD system the GPS systems, those were there and they were put in place to aid an administration part of a job to optimize it. They saved money for the enterprise by getting the right worker to the right place at the right time, and it worked very effectively. IoT and M2M has the capability in this scenario of speeding the work itself or eliminating it. Because if the system is sophisticated enough to fix a problem remotely, maybe you don't have to dispatch the technician at all. So that's the benefit there. I need to chat briefly about why this is happening now. First of all, think about your smartphone. The amount of processing power in your smartphone is phenomenal compared to what it was a decade ago. There are things in that device right now that would have taken a substantial PC or 2 decades ago a mainframe to accomplish. You have a device that is a communication, a storage device. It's a user interface. It has sensors for multiple activities. It's available right now, and the price of that product is less than $1,000. In a rugged computer environment, 10 years ago, a rugged computer would have cost you $3,000, $4,000, $5,000. Those would be reasonable numbers. They're now available below $1,000. And you can get that capability in the hands of your mobile technician who is out in front of the point of need. Could be a police officer, it could be a technician, could be a nurse. And it's at a price point that's competitive such that nobody should be without one. Add to that communications and storage. Your data communications, your storage capabilities, big data, WAN radio, wired internet, all of those capabilities are coming down in cost, and their bandwidth capabilities are just enormous and growing, and they're there. The business drivers around an industrial computing, M2M, IoT, present opportunities to an enterprise for a competitive edge. It won't be a permanent competitive edge, but in the long term that edge will turn to table stakes, but the one who gets there the first will be the one who can leverage it in the long term. For a service enterprise, and I think of a hospital as a service enterprise, you end up with fundamentally flawless performance. If you get flawless performance, what do you get? You get customer satisfaction and you get customer loyalty. That would be their competitive edge. Conclusion on this? Very simple. Voice presents some immediate opportunities. The cost reduction alone is worth taking a look at it. Productivity improvements come out of mobile devices put in the hands of people who are using them when they're at the point of need. You can automate processes that people use typically for experience, and you need to expand upon that. They deliver user safety. If somebody did not have a means of communications, this is another. And then when you add M2M and IoT, rather than dispatching people who are fixing stuff, you're dispatching people who are repairing product that you know needs work. It could be people who are working on product that needs materials, and I think of a vending machine, and you're dispatching them to fix that or to add to that when they need it, not when the schedule suggested it. And that, to me, is what the benefit of this new technology is. The lowering costs are letting us get deeper into the enterprise and closer to the point of need. Thank you.